Hello, welcome to week 13, chapter 6, lesson 6. In this lesson, we are going to discuss about function operations. At the end of this lesson, you should be able to find the sum, difference, product, quotient, and composition of different functions. Now, let's proceed to the content of the lesson for the week. In this lesson, we are going to discuss a key concept on how to perform function operations, and we will see some problems concerning about finding the sum and difference of function, and then we will see how to multiply and divide function, and then we will see composition of function, and finally we are going to see the application of composition of function. As usual, at the end of each problem, you should practice the guided question from your textbook. Now let's go to the key concept. The key concept about function operation. Let's say we have two different functions. Let's say it is f. We have f of f and g. The sum of these two functions can be expressed as f of x plus g of x. The same is true for their difference. F minus g is the same as f of x minus g of x. The same is true for their product and for their quotient. One important thing that you should consider regarding the operation of function is whenever you try to find the domain. The domain of the sum or difference or product or quotient of the function will be the domain of the x values that define each of the function. That means, in another word, whenever you operate different operation, their domain will be the common values of x for each of the function. We will see this one in examples. Another key concept is concerning the composition of a function. The composition of a function t with a function f is written as gov and is defined as g of f of x. The domain of g of f of x is the x values in the domain of f of x, where f of x is the domain of g of x. Another thing that you should consider, the composition of a function is not commutative. And whenever you try to evaluate a composition of function, let's say, for example, you want to evaluate g of f of x, you need to evaluate first f of x, because f of x is an input value for g. Then, finally, you will evaluate g of f of x. Okay? That is about the key concept regarding the function operations. Now let's proceed to problem 1. In problem 1, you are asked to find the sum and difference of function. Let f of x is 4x plus 7 and g of x is the square root of x plus x. What are f of x plus g of x and f of x minus g of x and their domain? First, let's find their sum. From the key concept, we saw that f plus gx is the same as f of x plus g of x. And substitute f of x and g of x and combine like terms. You get 5x plus the square root of x plus 7. Here, what will be the domain of this function? The domain will be all values, the set of all real numbers which must be greater than or equal to 0. Why? Because we have the square root. Let's find the difference of this function. F of x minus g of x. Substitute f of x and g of x. Apply distributive property. And finally, you'll get 3x minus the square root of x plus 7. Here also, the domain of this function is the set of all real numbers greater than or equal to 0. The domain for f plus g and f minus g will be the values of x in both f and g. Since the square root of x is defined for all values of x greater than or equal to 0, the domain for the two cases, that means for the same, difference will be x is greater than or equal to 0. This is problem 1. Let's go to problem 2. In problem 2, we are going to find the product and the quotient of the function. Let f of x is equal to x squared minus 9 and g of x is x plus 3. What are f times g and f over g? And find their domain. Let's find their product. F times g is the same as f of x times g of x. Substitute each function and multiply them. You'll get x cubed plus 3x squared minus 9x minus 27. What do you think will be the domain of this function? The domain will be all values of x. All values of real numbers, in another word. Let's find their quotient. F of x over g of x. Substitute each function. Here we can factor x squared minus 9. X squared minus 9 is the same as x minus 3 times x plus 3 over x plus 3. Because division by 0 is undefined, here x cannot be negative 3 because negative 3 makes the denominator 0. Then let's cancel out x plus 3 by x plus 3. And finally, we'll get x minus 3. Domain of f times g is a set of all real numbers, as we said earlier. But here, for the quotient, because division by 0 is undefined, x cannot be negative 3. Therefore, the domain will be all real numbers, the set of all real numbers except negative 3. This is problem 2. Now, let's proceed to problem 3. In problem 3 is about composing function. Let f of x is x minus 5 and g of x is x squared. What is f of g of negative 3? That means you are going to compose function f with function g when the input value is negative 3. First, let's define f of g of x. And let's substitute in f of g of negative 3. G of negative, then evaluate g of negative 3. That means plug negative 3 in g. That is, it will be negative 3 squared. Negative 3 squared will be 9. You'll get f of 9. Now, 9 is an input value for f. It will be 9 minus 5, which is going to be 4. It's problem 3. Now, let's proceed to problem 4. Problem 4 is the application of the composite functions. You have a coupon good for $5 off the price of any large pizza. You also get a $10 discount on any pizza if you show your student ID. How much more you will pay for the large pizza if the cashier applies the coupon first? Here, let's define the variable C and D for the function for the price when the coupon and a discount and when a discount applied respectively. And let x be the price of the large pizza. Therefore, we can define the function for C. C of x will be x minus 5 and g of x will be x minus 0.1x, which is going to be 0.9x. Suppose the cashier applies the discount first. That means we are going to evaluate d of x first. That means it will be c of d of x. C of d of x will be, let's substitute d of x by 0.9x. Then 0.9x will be an input value for c of x. We will get 0.9x minus 5. This is when the cashier applies the discount first. Suppose the cashier applies the coupon first. In this case, it will be d of c of x. So d of c of x will be d of x minus 5. Then x minus 5 will be an input value for d. That means we'll plug x minus 5 in d of x. It will be 0.9x minus 4.5. Know how much more you should pay if the cashier applies the coupon first. You should take the difference of the composition of the two functions. That means 0.9x minus 4.5 minus 0.9x minus 5, which is going to be 0.5. That means you must pay a $0.5 more. So these are all about the lesson regarding the the function operation. We will practice more on the live discussion that we are going to have for week 13. Thank you very much and goodbye.